Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of solutions for systems of equations. This is standard A.3F in the great state of Texas, and we are using item number 49 of the 2019 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got 4 graphs. Each graph here has 2 different lines graphed on them. And we need to find which graph best represents the system of equations right here and its solution. So what do we know about a solution? Well, a system of equations, when you have 2 or more lines graphed on the same graph, solution is something that's going to satisfy both and turn them into true statements, right? So we want an x and a y that's going to turn this first one into a true statement and this second one into a true statement as well. So if that's the case, you know what we would need is we would need the intersection. So we're looking at these intersections right here. Which of these xy coordinates for these intersections could we put into both systems and get true statements? Now we've got 2 options. First, we can use the substitution method. So we could just take each of these, 0, 2, or negative 2, 0, or 0, negative 2, 0, positive 2, plug them in and see which one gets you 2 statements. I'm going to do a different method. This is called the elimination method, but that first method could work as well. That's the substitution method. So what we're going to look at is first we need both of these in standard form. We need it into the ax plus by equals c, and they're good. Now, what we need is we need to find something in which we can get these 2 equations to eliminate if we were to add them. I want to eliminate one of the variables, and I don't necessarily see any of them that's lined up like that, but you know what I could do is you can actually multiply both of these, okay? So what I'm going to do is I'm going to multiply this first one, right? This 8x minus 4y. I'm going to try to get rid of that x equals negative 16. Watch what I'm going to do. I'm going to multiply both sides by 3 because I want to get that 8x into a 24x. Okay, so that's going to be 24x minus 12y equals negative 48. So I'm going to put that right here. 24x minus 12y equals negative 48. Now, if that's going to be 24, I need this 3 to be a 24. So I'm going to multiply by 8. But since they're both positive, I need to multiply that by negative 8. So 3x plus 15y equals negative 6. If I multiply both sides by negative 8, now I'm going to get a negative 24. That's what I'm wanting. So negative 24x. And then negative 8 times 15, so that's going to be, 120 minus 120. That's going to end up being a positive 48. All right, so look at my systems of equations now. Right, these are the exact same lines. All I did is multiply both sides to keep it balanced. That's interesting. Take a look at that. The 248s worked out as well. Not necessarily what I was hoping for, but that's going to make it a lot easier. Watch this. So if I add these 2 equations here, all I was trying to do is get rid of the x's, right? So 24x minus 24x, that's going to get you your 0. That's what I want. So I got a negative 12, right, and a negative 120. So that's negative 132y. But now I've got a negative 48, and then I've got a positive 48. So that's just 0. Okay, so now I need to solve for y. All right, so negative 132y equals 0. That's pretty easy. Divide both sides by 132 negative. What do you get? Y equals 0. All right, so there's my y. And then I just plug that 0 into any of these equations, right? So I'm going to do 8x minus 4. I'm going to put the y into that equals negative 16. So 8x equals negative 16. So divide by 8, x is going to equal negative 2. So here's my solution, negative 2, 0. And my answer here is B.